like to discuss about the multiple processor organizations. Nabila, can you give me a brief about this topic?
Thanks, Ain, for setting the stage for us. As you have heard today, we're diving into multiple processor organizations, a topic that's central to modern computing. Imagine your computer or your phone running at its fastest, doing more tasks, handling more data, and never slowing down. Well, that's where multiple processors come in. They allow multiple processors to work together in harmony, making systems faster and more efficient.
Thank you for information, Nabila. Today, I would like to introduce the type of multiple processor organization. First one is asymmetric multiprocessor. All processors share a single memory and input-output resources. Each processor runs its own tasks and can execute any process or thread. Efficient load balancing and fault tolerance. For example, multi-core CPU in personal computer. Other than that, we have an asymmetric processor. Processors are specialized, with one acting as the master and other as slave. The master processor can handle system-wide tasks and assign work to slave the processor. It is also suitable for systems where tasks can be easily divided hierarchically.
Thank you for your explanation, Anne. So, I agree and I want to add some type of multiple processor organization. They also have cluster computing. This is a type of distributed system where multiple independent computers work together in a single system, often using high-speed network and middleware for coordination. For example, is high-performance computer cluster.
Sorry to interrupt you, Ada. I just like to share with you all about the features of multiple processor. I think the features of multiple processor is awesome to me because these features enable multiple processor system to handle complex tasks efficiently, making them essential in modern computing environments. The first feature is scalability. Scalability of multiple processor depends on memory bandwidth, integration efficiently, and task distribution. More large the system, more processors are needed. So that's why a lot of processors are allowed to handle large workloads. The second feature was shared or distribution memory. For shared memory, all of the processors access a common memory space to fast data sharing, but also requiring synchronization mechanism. For distributed memory, the processor has its own memory. The third features are interconnection networks. Interconnection networks is important to communicate and share data among processors, memory units, and devices. This network is important because it can improve system performance and can achieve parallel processors. The fourth feature is the task synchronization. Last but not least, task synchronization is important to ensure that the processor is in a coordinated state and can perform the task correctly. Use a variety of techniques such as locks, semaphore, and barriers to provide consistent access to shared resource and prevent race conditions. Okay, that's all.
Now, I want to add some point about the features. It is a load balancing. The workload is distributed evenly to avoid overloading any processor. As a result, the processor can work optimally. And lastly is fault tolerance. The system can still perform operation even if one or two processors are damaged. This is because the system has the redundancy and error correction mechanism. So Ada, can you continue the next content?
Okay, sure, Anne. So now, I want to explain about application of multiple process organization. simulation. It's about take weather forecasting. It's all about climate change, risk and affairs. So you need high performance processor with lot of cores. Then for business, like web hosting or banking, it is about reliability. Multi-threading ensure everything runs smoothly under pressure. Then there is AI training with your network. That's where GPUs and TPU size handle crazy amount of net in parallel. For gaming, real-time graphic and physics demand super speedy GPUs for those smooth stunning visuals. And for everyday stuff like IoT or robotics, it's all about efficiency, low power and quick response. So every application gets its own processor design, and that's how we keep the world running.
Thanks, Ada, for the insightful explanation on the applications and advantages of multiple processor organizations. It's clear how they are revolutionizing technology. However, as promising as these systems are, they are not without their challenges. So let's take a closer look at some of the hurdles faced when implementing multiple processor organizations. First, the complexity of design is a major issue. As we add more processors, the system becomes more difficult to design and manage, ensuring that all processors can communicate effectively without causing delays or more errors requires advanced architecture. Another challenge is synchronization. When multiple processors are working on different tasks simultaneously, they need to stay in sync. Without proper synchronization, tasks can get mixed up or delayed, which can be a nightmare for performance. And then there is the cost factor. High-performance systems with multiple processors are expensive to build, which can make them less accessible for smaller organizations or personal use.
Sorry to interrupt you, Nabila, but I just need add to more of challenges. We also face software compatibility challenges. Not all software is built to leverage multiple processors, and making existing program compatible can require significant modification. And finally, the power consumption and heat generated by multiple processors can be a problem. More processors mean more energy use and more heat, which requires effective cooling system to avoid overheating.
Even it has many challenges for this processor, they also have their advantage. First, increased computational power and throughput, whether it's stimulating vector pattern or training AI. Specialized processor handle huge workload faster, more efficiency. Next, improve fault tolerance and reliability. In systems like baking and web hosting, downtime is an option. Processor design here ensures smooth operation even under pressure. Then there is enhanced resource utilization. For gaming, for example, is user every one of GPU powers to reduce stunning visual and seamless performance. Nothing goes to waste. Finally, better cost-performance ratio. Embedded systems like IoT device focus on doing more with less low power, high efficiency, and affordable to deploy. So, whether it's a strict reliability and or cost tolerant processor organization ensure to get the best performance for every application.
Okay, we are already complete for all the content of the multiple processor organizations. Can I really conclude for this multiple processor organization topic?
Alright, Ain. Okay, to wrap things up, multiple processor organizations are an essential advancement in modern computing. They offer remarkable performance, improvements, scalability, and reliability, but as we have seen, the complexity, synchronization issues, high cost, and power demands are some of the obstacles that need careful consideration. As technology continues to evolve, these challenges will likely to be overcome, and we'll see even more efficient and powerful systems. Thank you for joining us today as we explore this fascinating topic of multiple processor organizations.
Alright, thank you Nabila for the amazing conclusion.